Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
As your system scales, eventually you'll find that your database is the source of all of your problems. Apps are often a lot easier to scale than databases, but eventually you have to deal with the database itself. In this episode, we're going to talk about database sharding, which is a useful method for helping your data access scale. But before we get started, Will, what's been sharding your data? Is that what you're going to say? I was trying to think of the best way to put it.
I was just thinking, man, when I wrote that, I was like, man, he's going to have something to say there. And there's just no good way it could go.
It was a matter of picking which one.
Yeah, I know.
Say.
It's like a target-rich environment, like you're paralyzed for choice.
Right.
Yeah. So yeah, it's been 3 weeks since we recorded? 2 weeks. I'm trying to remember.
3 weeks ago.
Yeah, it's 3 weeks ago. So I've been doing I did a lot of Nest.js stuff, then WPF stuff, then Next.js stuff, and now I'm doing Dart and Flutter. So I'm all over the map on stuff at work right now, which is good. I'm not bored. So that's what I got going. But yeah, while you were gone, I've been just cramming programming tutorials just as fast as I can go. So yeah, that's about it. How about you?
Well, I have been in Europe for the last 2.5 weeks, roughly. Yeah, it's been fun. Started off in Albania, helping out the church there. There was a men's conference. Got to meet some pretty cool people from the Christian Men's Network. One of them, Pastor Steve Mack from Berlin. He's actually from one of the Carolinas, but he pastors a church in Berlin now, and wrote a really cool book that he gave me a copy of. One of the few copies in the United States.
Is that this one?
No, that is the book that was about the men's conference. This one is by Pastor Steve Mack, and it was about being home, like anywhere you are. And so even if you are on a 1-year visa, making wherever you are home. And so it was really good. I read it on the flights to from Albania to Glasgow, and marked it up quite a bit. Took a lot of notes in that book, so it was really good. But yeah, that was really cool. Spent a lot of time with the tech team at the church, and did some photography and some training on that stuff with them, and got to go and hang out at the city radio tower in Tirana, Albania, and met the owner of City Radio and a couple of TV stations while I was there. That was really neat. One of the guys at the church does some tech work for them, and so he also has a really cool YouTube site. So shout out to Daniel there. So that was really cool. But yeah, it was a lot of fun. It was a great trip. Spent a few days in Scotland, made a pilgrimage to the Robert Burns Cottage and Memorial and Museum, and got to walk across Brigadoon and the old Kirk and just all sorts of places that he wrote about. And so that was really cool. Actually, I skipped out on the rest of the tour and stayed there in Alloway. Because I asked, we only had an hour, and apparently nobody really is that interested in that part of the tour, and it's just sort of tacked on because we're over by that. And I was like, that's why I signed up for this tour.
Yeah, you're the weird guy. You just got to go do your thing.
Yeah, and being on my own on this trip, it was great because I just went up to the tour guide. And I'm like, we only have an hour, and he's like, is that not enough time? I'm like, this is the reason I signed up for this tour. I'm like, the castle was cool, but I've seen castles before. It wasn't that big a deal. Got some great photos, but I really came here for this. And I told him about like the family connection. He's like, I've never had anyone on my tour who actually had a family connection.
Yeah, because they all came to America. Yeah.
Yeah. So anyway, that was cool. And then my last day in Europe, I took a train from London to Paris, which what surprised me was the part under the English Channel was really short. I mean, of course, we're traveling pretty fast, but like it was mostly outside through the countryside, getting to the Channel, like getting there from London and then getting from the Channel to Paris.
How long is that trip? And the Channel or whatever they call it.
The whole trip was, let's see, we left at 8 and got there at about 11:20, which would have been 10:20. So
31 miles.
Yeah. About 2 hours.
Well, the Channel itself is 31 miles.
Oh, the Channel itself. No, I'm just saying the trip, the whole trip was a little over 2 hours.
Yes. And looking it up on Google, they say that's the equivalent of 169 Eiffel Towers stacked on top of each other, because apparently we just really don't want to use metric. How many libraries of Congress is it?
Yeah. Yeah. Oh my goodness. Yeah.
So anyway, how many giraffe-sized asteroids is it? Can you get it in those units, please?
Yeah. My goodness. Yeah. So I went to Paris, hit the highlights. I only had an afternoon basically because I met Julian, our editor, for lunch. He took me to a bouillon, which is a French type of restaurant, which is really cool because we went in and we said it was just two of us. They sat us at a table for 4 with 2 other people that we didn't know. And that is apparently a thing in France. And I was like, I love this. This is so awesome.
Yeah, I kind of think that may be why, France, like why they have the amount of protests and stuff, is because people are actually able to sit down and talk to each other and talk to people they haven't met before.
Oh,
it's
yeah.
like the networking there, probably contributes a lot to that.
Yeah. But yeah, anyway, it was really cool. Just really enjoyed hanging out with him, getting to know him. Surprisingly similar. Like he's a few years younger than me and we have a lot in common. So we sat and talked for a while, just, getting to know each other. It was fun. Like
nice.
That was really awesome. Definitely a highlight of the trip was getting to have lunch with Julian and like meet in person someone we've been working with for, I don't know how long, several years now. Yeah.
I don't know how many.
So
like the other day you told me, it's like, oh yeah, we've been doing the podcast like 8 years. And I'm like, has it been that long?
Yeah. Yeah. So, speaking of people we've been working with for a few years.
Saving money is hard, especially when you go gallivanting all over Europe.
Yeah, but it is so worth it, man. Lucas Quesadas is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like us at Complete Developer Podcast, he focuses on helping you to not only establish a real plan, but also to take action on that plan so that you can live your best life, so that you can do things like go to Europe.
Because investing in financial planning services really comes down to whether or not you can improve your finances. And with the help of Level Up, the compounding impact of making those better financial decisions will easily pay for itself. And if you're like me, end up in Euro trips. Wait, that sounds like a movie.
Probably is. Level Up also has a unique pricing model that will help you no matter where you are in your financial journey.
And best of all, Lucas is a fiduciary for his clients. And that means he's not there to sell you a product, but to help guide you to a better financial situation.
And you can catch his podcast, Techie Personal Finance Bootcamp, where he covers financial topics that you probably face. And he interviews other IT professionals who share how they navigated their own careers. And you can learn even more at levelupfinancialplanning.com.
So let's start off this episode.
Yeah, but with the obvious thing we need to say.
Yeah, saying we're talking about sharding with a D, not a T, as many times as I picked on Will as he was working on this episode. It is sort of comical that the two words sound so alike.
Well, at a certain scale, those are your two choices. Right.
Yeah.
Yeah, and you really don't want the other one.
Yeah. So database sharding is a process of storing a large database across multiple machines. because a single machine can only hold and process so much data. Eventually, some systems will scale beyond the ability of that single machine to handle data. In addition, as systems scale, they may also need to split data between machines due to security and location considerations. Database sharding overcomes these problems by splitting the system into smaller chunks. And this allows work to either be done in parallel or only in the location with the relevant data.
Yeah, or both in some
Yeah.
circumstances as well. Obviously, it matters a lot how you split up your data. For instance, it's unlikely that splitting a customer table based on the customer last name will be as helpful in a large distributed system as it would be to split up customers by location. You probably also want to have shards that are kind of roughly the same size. The idea behind sharding is to improve performance, especially by way of parallelization. But it's also helpful if it also provides some resilience to outages. So that will also need to be a consideration when you start thinking about sharding.
So, in this episode, we're going to discuss database sharding and how it's done. And after that, we'll talk about some things that you need to know when optimizing for sharding and alternatives as well. We'll finish up by discussing some situations where sharding is not the best approach. This content really heavily leans on the excellent AWS guide to sharding that Will found. And you find that link in the show notes. Great. Now I've got to put it in the show notes. Thanks, man.
Yeah. Well, copy paste this is one time a developer gets to copy paste and gets thanked for it, right? Yeah. But like I started doing the research and then I found that article and I'm like, man, this like hits everything. Every question I went there to answer, like it had the answer. And I'm going, well, crap, Yeah, they do a good job on their docs.
I'm just proud of you. You actually put the link in the references section of the outline. Way to go, man. That's going to help me. I probably will forget about it, but
Yeah, you will. That's okay. Feel free to message him on our Slack channel and give him some crap if he forgets it.
Please do. It'd be really good for me to
receive the healing.
Yeah,
from our fan base.
Yeah. So, all right, let's start off. How does sharding work?
Yeah, so databases are sharded into partitions I kind of don't overly like using that term because there's also partitioning, which is another thing. And there's also hard drive partitions, which is yet another thing that's unfortunate. But each partition, shard, or node, and we'll probably call them shards for this reason, contains unique rows of information. Each shard will share the original database's schema. And you should note here that this also typically includes lookup tables because those are going to have to be duplicated across the shards for things like foreign key constraints and that sort of stuff.
Since you mentioned it, why don't we go into the difference between sharding and partitioning really briefly?
Well, it's basically the difference of, do I have all of the data in this database, or do I, am I splitting the load? Am I duplicating data, or am I, or how am I splitting tables? And what a shard is you have separate databases. Whereas, the partitions, if you're partitioning a database, you might have one table on one drive and another table or another part of that table on a different drive.
Yeah.
So that you're using different physical hardware. So like it's one of those things that scales up. So yeah, and we'll get into that here in a minute, but there's a reason I wanted to clarify and be really careful about the language.
Yeah.
Which is why we're using a word like sharding to talk about splitting a database, because we would not be using a word like that if we had a better choice, because you saw just how mature we just were.
Well, I'm hoping that gets edited out.
Yeah.
But,
Well, okay, but you probably can project even if it does get edited out. So let's be honest.
Shards are identified by a shard key to determine which partition receives a given record. Now, typically, these keys come from an existing column, or a new column is generated, usually from existing data.
Right. And you can think about this as being somewhat similar in some characteristics to the sort of things you look at for a natural key or a foreign key, except there's not uniqueness. It's just, hey, this kind of buckets this thing in this group. is the better way to think about it. Sharding also operates on a shared nothing architecture. That is, each shard is unaware of and independent of other shards, and it operates on its own. Only the shard that or shards that contain the data that you need will process your request in parallel. So like if you had a shard for the southeast and you had a shard for the northeast, and you had shards for other parts of the country, but maybe you're like, hey, I want to get the everything east of Mississippi, I want to break it down for some sales region. Well, you might hit 2 shards for that query, and it's going to execute in parallel on those 2.
Okay, I see what you're saying. Yeah. Yeah. Now, this also means that a software layer will need to sit on top of the shards to coordinate that data access.
Yep. And if your database server does not do that for you, do you know who's writing it?
You are.
Yeah. Either you are, or you find out how to dodge. Because somebody's writing it. It's not going to be as clean and fun as you probably think it is. Because what happens if you have a partial failure? Yeah. So, and we're not going to go crazy into getting into that, but there are some considerations there.
Yeah. So now let's talk about some common sharding methods.
Yeah. So the first one is range-based sharding. When you do range-based sharding, you split database rows on a range of values. So a good example of this might be splitting a customer table based on the first letter of a customer's last name. Don't actually do this, more than likely, but because it's not useful and your distribution's uneven and there's lots of other problems with it, but people can reason about this.
Yeah. As soon as you said that, I was like, why would you do that? And then you're like, okay, it's a thought experiment.
This is what you do for Acme Corp when you're showing how to shard a database in a YouTube tutorial.
Yeah.
That leaks connections because you don't do everything else right. Yeah. So just for example.
Okay. So this is Stack Overflow code is what I'm hearing.
Yeah. I mean, obviously now real production, you wouldn't do this, but this is just for the purposes of explanation.
Now, when persisting a record, the system would look at the customer's name to figure out which shard gets the record. On the same note, during lookups by last name, the system will reverse this process to find the record. A search that doesn't contain the last name would likely be executed across all shards.
Right. Which obviously that puts a lot of load on the system that you probably don't want, because this is a thing that you are doing to get rid of load or to limit it. So you're probably going to be looking at something like Elasticsearch and not doing this crap on your database at that point. But that does kind of bring up a point, right? Like if you don't have the thing that makes the shard key, how do you know which one to execute it on? And the answer is, well, you either look at other ambient data to try to figure that out, or you just run it on all of them. So this is a very, very serious limit that you're going to run into if you're not careful. And there's another little bit of fun, because unless you have a fairly even distribution between those buckets, so like last names, for instance, in the US, there's like an actual breakdown online. I actually found this. I'd have to go find it again. But, there's certain characters that are very, very common as the start of a last name, and certain characters that are just not. Like you don't see a lot of U's for a last name.
Huh.
Right?
I can think of 2 off the top of my head, but of all the people I know.
How many S's can you think of besides every Smith that you know?
Excluding the Smiths?
No, they're in the mix too, right? So that if it was sharded improperly, most of the load's still going to one place. So you really haven't gotten rid of the problem. You've maybe put it off, but you added a whole bunch of work when you have to remediate it next time.
Yeah, that makes sense.
Now, it is easier to reason about this, which is the reason people go this way, and why we're explaining it this way is because of that.
Now, the next common method is hashed sharding. Hash sharding assigns a shared key to each row by using a hash function, and the hashed value is then used to look up the shard.
Right. But shard key, not a shared key. You've been reading too much encryption stuff.
I did.
Yeah.
Yes.
But it's all good. Just to go ahead and say that. Yeah. So in this case with hashed sharding, when you're persisting or retrieving a record, the hash function would be run to figure out which shard to run it against. So in this case, you might do that based on last name. And then you basically have an algorithm that evenly distributes the hash. And the way that you guarantee that is you find a mathematician that has actually worked this crap out. And then they'll tell you on, it'll be on the tin, basically. Like, you're not going to write this code yourself. You're going to use some known hashing algorithm, because you're going to also want to avoid things like collisions and that sort of stuff in some cases. Well, say that actually you do want collisions, because that's how you group them, but you're probably still not writing this yourself, because it is hard to mathematically prove that the output of a hash function is going to be evenly distributed within a set of data that you don't really control and that is continually adding more.
Reminds me of a conversation that I overheard on the train to Edinburgh the other day. This two, I'm pretty sure they were students. We're talking about group theory. Like, they're like math masters or PhD students. I don't know at what level, but yeah. And I was just like sitting there pretending to read a book, listening to their conversation, going, I understand about every third word they're saying. This is interesting.
Yeah.
And not because it's in a foreign language.
Well,
unless you count math a foreign language. But yeah.
Scottish.
Oh, no. Neither one of them were Scottish.
Oh.
Were they British? One was American. Or Canadian. It's kind of hard to tell sometimes, especially when you've been around like over there so long. Like, it no offense to the Canadians, but we do kind of all sound similar.
Yeah. You gotta like count the apologies per minute. Because they're like politer.
That is true. That is very true.
It's substantially so. You could probably like, that'd be your heuristic. You're just like, oh, they're nice. They must be Canadian.
Yeah, because if they were like superficially nice, they'd be Southern.
Yeah.
Saccharine sweet.
Yeah.
Sorry. Okay, we were way off topic.
Yes, we are.
So back to hashed sharding. The downside is that it's harder to reason about this setup because it doesn't separate rows based on the meaning of the information. This can make it challenging to think about where a record will go or what to do when you want to add more shards. Like, how do you create new shards?
Right, because now you got to go, okay, I got to do a different algorithm and then rerun all the crap. And like, how many shards does this overlap with? Oh, wait, it's going to overlap with all of them potentially because I'm trying to do something to get a, like...
Yeah. No, you'd have to like redo the whole database if you're... So I was like, you could use the same algorithm, just pass in like different number of shards, but then you'd have to like reset the whole database to do that. You couldn't just like shard to shard.
Yeah, well, I mean, I guess you could probably, or you have a secondary shard.
Like shards, so we sharded your shard.
Yeah, yo, dog.
Yeah.
I feel like this is where you get a promotion at another company. It's like, honestly, by the time you're at the point where you're probably doing that, you should be at a revenue point where you can actually look at this problem, in a better way.
That's true.
Yeah. And it does have the advantage of more evenly distributing the rows between the shards. So you should be able to vertically scale the shards for some time if you started out with enough of them before you start having to reshuffle.
Yeah.
Now, another common sharding method is directory sharding. So what directory sharding does is it uses a lookup table to match database information to the corresponding shard. So, for instance, if you have a nationwide, company, actually the company I work for right now, initially the databases were sharded by location, like too much. So it was like a major data project to get it all together because it wasn't a real sharding algorithm. It's just everybody had their own copy of the system. Yeah. And that's fine, right? That's what happens when a company grows and, there's historical reasons, and it's all in one now. But you might have a lookup that says, hey, it's not necessarily geofenced. It's more like, hey, which market is this associated with? So like you might have one market that's based around a particular airport. So it's not like, okay, yeah, city of Nashville, sure. There's one real airport, and then there's a couple of smaller ones that probably aren't relevant for you. Whereas there are cities like Dallas where you got 2 airports potentially in the mix. Or, there's Dallas, Fort Worth, and all that. So you might have kind of a different identifier that's sort of like a proxy for geo, but it's not. really geo. It's just like, hey, here's the bucket we put them in for our company, and it's arbitrary. And so that's what you're doing here.
Okay. I'm just like slowly wrapping my brain around what you just said.
Yeah, because we're going to talk about geo here in a minute.
Yeah. Yeah. Still comprehending what you just said. It's kind of thick there, and I skimmed through this on my phone on a train, so I didn't really go in depth, and I haven't done a lot of sharding.
Yeah, I mean, I don't think most of us have, right? Like,
Yeah.
especially with all the cloud stuff now. There's a lot of things that are built into platforms, or we structure things differently, but you're still going to see this. But basically, when an application needs to interact with the data, it will first look up the shard based on the table. Which, by the way, that also means that table has to live somewhere.
Yeah.
So, is it in your database? Maybe. Like, how is that going to be structured? You're going to have to think about that. But it's going to have to do the lookup there first, and any query that involves that field, or involves where it can go to that field, then you're going to hit that table to figure out which shard. Otherwise, you're probably going to have to hit all of them.
Okay. I'm following here. So this has the advantage of being very flexible, as well as easily discoverable by developers, because you've got that table. Like now I'm starting to it's starting to click. Like I just had to chew on it for a moment.
Yeah. It also has the advantage or the disadvantage of being very flexible, as well as by being discoverable by developers. Because what are we going to do? That's going to be a shortcut. Oh, well, I'll just add another thing to this table and we'll just spin up another database, right? That may or may not be the ideal thing, is having developers decide to add infrastructure that costs money month over month. So just understand that plus can be a minus real fast. And it can get hairy quickly too if that table ends up with incorrect data in it, or if you need to split a shard, or move a chunk of records out of two different shards to make a new one, depending on what you're structuring on. That's entirely possible, right? So think like electoral districts, and all of a sudden, oh well, Congress redrew the map again, because that's what they do in their off hours. And we've got to shift this chunk of people around, and that's probably not going to be a good, it's not going to be geo sharding. It's going to be some made up crap.
Yeah, rarely ever it is actual geo when it comes to congressional districts. I have my thoughts on that I'll keep to myself to avoid getting into politics.
But, well, it's a way to control things in lots of ways.
That's where I was going. But, yeah. So now on to what Will hinted at earlier, and what got me a little confused with where we were, is geo sharding.
Right. And that is going to actually store information based upon geographical location. So, this is Latin long versus it's something more ephemeral, like a market that may be a little fuzzy at the edges. It's like, no, it's within this geofence that goes to this database, which obviously means you have to have that data, and it has to be fairly static, as well. So you might split based on country. That may be your geofence, and you figure out the position, you figure out which country it's a part of. Obviously, that is not as static as a lot of people would like over time. So you do have to, consider that, especially in certain regions of the world. There are borders on this planet that are drawn in different places by different countries. So a great example of that is, there's been some, India and Pakistan have had problems. Obviously, there's Russia and Ukraine right now. There's Yemen and Saudi Arabia, and those borders shift a little bit. And so if you've got stuff around the edges, you're going to have to bear in mind that you may want to be able to move things from one shard to another if there is business logic associated with that too. Right? Because bear in mind, a lot of people have got business logic in their database,
which they shouldn't, but can't always avoid it.
Yeah, sometimes it's got to be close to the data because it just touches a lot of data, and you don't want to transmit that over a wire for processing. So, yeah, just bear that in mind, that is probably something you will see.
Now, this approach also allows you to locate shards closer to where their data will be used.
Right. Which, that cuts out a lot of, like your data center egress charges. If you're moving data between data centers, there's a cost, whereas a lot of times in the data center, it's either lower cost or no cost. again, you're going to also have to locate your front end code and everything that's talking to that system over there too, right? Like you can't just go, oh, we're going to put everything in the New York data center, then we're going to distribute the databases. That's not a financial decision. But there's ways you can kind of play with this stuff a little bit. And that can really save you a lot of money. And it can also really speed up the app. And potentially, if you've got SEO considerations in the mix, that's also going to bump up like your Google ranking and those kind of things because of the speed. And this approach is really advantageous if your data tends to be geographically segmented and or you access it in a geographically segmented manner for whatever reason. And honestly, a large percentage of data really is this way because that's how that's how humans organize ourselves. We organize, in space, not like space, but like, 3-dimensional geographic space, like walking around.
Yeah, just don't look at my office. It's not very organized right now.
Yeah, I was looking at that.
I've cleaned out my storage room and I've been going through stuff and like,
I'm looking at your office now. It looks like you're going through stuff.
Yeah. I've been like, it looks like I'm moving in.
Trauma.
Oh, funny.
Yeah.
No, I've just been sorting and going like, you know what? I just had this sitting in storage and I don't even have a CD player anymore. So I need to just get rid of these CDs, stuff like that. But yeah. Now, the downside to geo-sharding is what happens when data needs to move or when the data has very uneven distribution. It also adds complexity when data needs to cross a boundary. For example, this would work very, very poorly for a social network.
Yeah. Or a logistics system.
Yeah.
Which I'm aware of some that are like looking at this kind of stuff now and going, how are we going to split the system between, potentially multiple countries, but even just, one country, just the US. That's, that is a very nasty problem. And I have a feeling I'm going to be in the middle of that one, but yeah. So let's talk a little bit about optimizing sharding and keys. Now that we've kind of talked about some of the algorithms that you might commonly use, and there's some terms that we need to kind of get into here. So the first one is cardinality, and cardinality describes the possible values of a shard key. It determines the maximum number of shards. So for instance, if a developer uses the first character of the last name, only in English, mind you, then the maximum number of shards would be 26. Right?
Yeah.
That's the cardinality of that particular shard key.
I was just thinking about it because
how many cardinals can the Pope have?
Well, I was just thinking about like when you say that in English, like here's a tricky thing for you. There's 36 letters in the Albanian alphabet, and several of them are just like double character letters.
Yeah. Well, I was thinking like Mac in English, right? There's enough McGregors and McDonald's and
yeah.
Or O, yeah. So that's not a perfect thing, but they probably would still just go well. Just put them in that bucket and do a quick ASCII, slice and dice on it.
Frequency is the probability of storing specific information in a particular shard. For instance, if you were to use a person's age as a shard key, this is not a good idea since, that tends to change over time.
It changes till it stops changing and then you're probably not tracking them anymore.
Depending. I mean,
yeah.
You may work.
Well, going back to the voter registration example.
Wow. I thought we were going to avoid politics. Anyway, you're using age as a shard key for a system that tracks CrossFit gym memberships. Oh my goodness, dude. Then most recent records might be in the shards handling 20 to 40-year-olds.
Right. You're probably not going to have, anybody in the group 1 to 10, for instance. You're probably not going to have anybody in the group 80 to 90. You never know. There's always that one crazy dude, right?
I mean, I know some pretty spry 80-year-olds.
Yeah, but it's pretty intense, right? So, more than likely you're going to have a clustering effect there and a statistical distribution that does not work well for this.
Rod Stewart, I bet he does CrossFit. The guy's like in his 90s and he's like running around the stage. Sorry, I took my mom for her birthday, and like I was just amazed at how like mobile the man was at his age. So anyway, way off topic.
Yeah. So now we will talk about monotonic change. That is the rate of change of a shard key. So a monotonically increasing or decreasing key will result in unbalanced shards. So for instance, if you sharded a database based on how many purchases a customer had made, over time, more of your customers are going to cluster in the final shard. Right. And then eventually you're going to be like, oh crap, I got to add another shard for, to move some of these people. Does that kind of make a little bit of sense? I know like the monotonic thing it's just something to be aware of. Like, does this thing change? What's the rate of change? Am I putting it to more volatile data? So you could almost look at it as a volatile.
Monotonic. That's just a fun word to say. Guys, you should say that word, monotonic. It is a fun word to say.
But say it while changing your voice up and down so that you don't sound monotone, because that's something else.
So now we'll talk about some alternatives to sharding. And first is vertical scaling. Basically, you add more resources to whatever machine is handling your database. It's simple and should probably be done until it gets too expensive or difficult to scale much further.
Yeah. And by the way, don't go to the red line on this, because like the sharding thing is going to take a minute. And so like if you're already in trouble, it's too late. That said, don't start looking at sharding when you're like, oh, I'm on a small, database instance on Azure. Right. Okay. Well,
yeah,
it's small because there's mediums and larges. Go in that direction before you start, because it's going to take a lot of time, and it's developer time for this is not going to be cheap. And a lot of times when you plan ahead and you go, okay, I'm going to do this thing for this thing I can foresee in 5 years. Well, everything changes in 5 years. 5 years from now, maybe the app doesn't have the same load. Maybe it's gone. Maybe, you completely restructured to some other thing where the database is really not your problem anymore. Or you picked a different database and now a different database is your problem.
Oh, no, that happens.
Yeah. It's one of those deals where like the common thing in all your dysfunctional relationships is you. And that way with a lot of dev shops and database servers, unfortunately. So yeah, vertical scaling, that's probably what you want to do for a while. Another option is replication. So this is just essentially make a copy of the database and store the data the same across different computers. And a lot of database systems will allow you to do this. So you can go, hey, I've got 4 different databases and I'm doing some kind of load balancing type scenario with them. Now, that also means your writes are more expensive because they got to go into 4 systems and you got to deal with what happens if it fails in one.
Yeah.
So you are going to have to think about those kind of things. But that still is better.
I could see ACID compliance being tricky with that.
Well, it's ACID compliance per database.
Yeah.
Right?
Yeah.
And then on the... or, it's like ACID and then it's ACID for one database to get the data in and it's base for the others.
That's what I was thinking. Like if you like... Yeah,
I've seen some stuff that I didn't like. I'll just say that. But you do have built-in replication in a lot of these platforms and they handle it for you.
And then you've got partitioning. And this is the process of splitting a database table into multiple groups. Horizontal partition splits the table by rows, whereas vertical splits it by columns. This is done on the same computer, but may use different storage devices. And what it does is allows you to get more out of one single machine.
Yeah. So, and explaining the vertical and horizontal to developers who are not really database oriented, you can think of a horizontal split. You're splitting by rows. This is like the scaled down version of sharding a system. Whereas a vertical split is like the scaled down version of a microservice split.
That's a really good way of putting it. Like I visualized it using like a spreadsheet kind of. Yeah, I literally visualized it using Excel, and I'm like, okay, yeah, I can see that makes perfect sense. Just like open up a new sheet. Like if you think about a partition as a new sheet,
right? Or but when you say vertical or horizontal, they're like, what does that mean? Does that mean that's the line, or does that mean that's the cells? Because like they're these are vertical and this is, like people get confused on that. Whereas if you explain it the other way, it's like, hey, but it's based on the functionality, the functional way you're splitting it. Sometimes that helps people. So
I didn't get confused by that. It made sense. The rows are horizontal.
Yeah, you didn't and I didn't because we're in and out of databases
columns
all day.
are
but there's
vertical.
People that aren't. So
I don't know. I just know how tables work. I don't know. Sorry. It just like I've used some Excel spreads. Yeah, I've used Excel spreadsheets for so long, even before I got into development, that I just I'm like, oh yeah, I visualized that so easily.
But if you are horizontally splitting a sheet, right? You're splitting it along the vertical axis by a horizontal line, which is where people get their brain messed up. So I was like, okay, let's just explain this as based on the intent versus spatial.
I would never have thought that way.
Yeah. I know a dude who thinks that way. That's why I'm saying it.
Yeah. It just seems like you're overcomplicating it. And I'm just yeah.
I think he is too, but that's the way he understands these things.
Yeah.
So if you explain it by the intent, maybe that gets people further. And realistically, that is what you're going to be doing, right? When you're partitioning a table and you're saying, hey, these columns go over here. Well, that's probably a separate use case. You don't want to go, I'm doing this one query and it's split between these two partitions, because then now you're activating both, physical storage devices and you're not really saving yourself much. So, yeah. So let's talk about major problems in sharding. And the first one of these is hotspots. And we alluded to this earlier, but hotspots can occur because of an unbalanced distribution of data. This can mean that one machine is handling an inordinate amount of system load while the load is lighter on other machines. So you're overpaying for some machines and you are under provisioned for the one machine that's overloaded. So you didn't split the load well, essentially, is what happened. And now you're not getting all the benefit that you should. Now, whether this kills your app or not is a whole other thing. But it may point to a problem that could come later. This is the way I think about it.
Next is operational complexity. Instead of managing a single database, a sharded system will require the maintenance of multiple databases. It will likely also require additional work to keep things, common, such as the schema and various lookup tables in sync. Analytics are going to be a lot harder as well. Yeah, you got some complexity there.
Yeah, some of those things like analytics probably shouldn't be in your OLTP database anyway, but everybody does it. Everybody does it until they realize they have to stop. You're also going to run into more infrastructure costs. The database, in a lot of cases, is the most expensive part of the system as far as just, cost per CPU cycle, just because of the software that's on there. Maybe it's not as bad with some of the open source ones, but like SQL Server, Oracle, you're going to get a higher cost point for that. And when you shard the system, you're going to stand up several databases. And while, each of them is going to be smaller than the original, it's going to be larger than their fraction would be. So your total gets bigger, if that makes sense, because you're gonna want to move that stuff and have headroom after you move it. Because if you don't, when you find something wrong that you did and you have to do this expensive query and you're already close to your limit, it's going to be bad.
The last one is application complexity. Applications are also going to have to deal with the implications of sharding, unless the database management system handles it transparently. And we'll just say that transparently is kind of up to interpretation where this is concerned.
Right. And especially with like geo sharding, where you're in different data centers, there is going to be a difference in performance, calling across. And so, and potentially reliability. And so you're going to have to think about those things when you're building screens. Like, what do I do if 2 out of the 3 shards I'm calling work and the other one doesn't? And you're going to also have to find out some way of alerting the team that happened too. So let's also talk about why and when you shouldn't shard. And the first one is you still have plenty of headroom to scale vertically and or use other services to improve performance with less impact. So this would be stuff like I can stand up a Redis server and I can cache. I could get a larger SQL instance. I can, use a CDN for some of the stuff.
Next, you are using your OLTP system for analytics. This adds a lot of load to most systems, and it's just easier to split off elsewhere. And if you decide to shard later, you're going to still need to do this anyway.
Right, because you don't want them running the analytics across multiple databases. Right, because whoever's running that analytics that's hitting all the databases, I mean, you got to think about your organizational pyramid, right? It's the dude at the top that's hitting all your servers. And so you don't want it to be slow for them, and you don't want them to be able to knock the system down. Another case when you probably shouldn't shard, I'm not going to say always, but if your main issue is read performance, this tends to indicate that you should probably use caching and or database replicas without having to do a heavy rewrite.
Yeah. Also, if a lot of applications directly access your database, if that's the case and you shard, you'll be dealing with sharding issues in every single one of them, just about.
Yep. And it's not going to be the same code, more than likely.
Yeah.
Because there's a reason you're doing that, and it's probably to get around, like use multiple languages or something like that. And we're going to put logic in the database so we don't have to rewrite it in different apps. You'll see this in a lot of older companies, that those systems are still around. I've written them. It's the way it is. Another case when you shouldn't shard is when your database still has a small working set. So the working set is the amount of memory required for frequently accessed data. So it's basically a cache, kinda, of what the database is frequently hitting, so that it keeps it hot in memory instead of having to read it off the disk over and over again. If it's a small working set, you may get more bang for your buck by just increasing that first. Add more RAM, bigger machine, just step up. It's a type of vertical scaling.
Next, you don't want to shard if you have poor discipline around versioning of database objects. You can get by with a lot of crap in a single system that will be a disaster in a sharded one. And this is really one of the big ones for that.
Yeah. Never make one thing into many when you can't handle one thing. That's just a basic life lesson that you need to learn in general. I've seen this one hurt people plenty of times. So like if you deploy an index and you put it out to 3 of your shards and there's a 4th shard, and that one starts falling over in 6 months, are you going to be able to figure that out? Another thing that is why you shouldn't probably shard right now is when you're already getting negative feedback about your team's productivity. Sharding a good system is going to slow it down, and it's going to slow the team down. And if you shard a bad one, it will tank it. Like, you really have to deal with the organizational issues that are putting you in that political situation before you ask for more money for sharding, even if you need it right now. And that's why you want to be ahead of these things before, you don't want to hit the wall and then find out that you got to fix it when you're already politically in the stuff.
And finally, you shouldn't shard if you think Agile fits perfectly in every situation. This is an area where a big design upfront is required. You have to do that to prevent large amounts of expenditure and very expensive reworks. This is not something that can quickly and easily be redone. If your team is overly hung up on Agile or bad at it, this will be a failed project. And that's the thing. Like, it's something I've noticed. The lower or closer to the metal you get, the more planning you need up front. Like, your front end code, like the way that your app, your interface and the way that your app looks and feels, that can be adjusted pretty quickly. Your API, not as quickly, but it can be done. But when you get to the database,
you're starting to get to DevOps.
Yeah.
And, the other thing too is the expense. So like, if you're wrong on the API thing, you get errors and you can catch it. If you're wrong on this, you've potentially spun up another server, you've moved data, you've spent weeks. I'm not saying you can't do it with Agile. I'm saying most shops can't. And I will loudly assert that one, because most shops are very dysfunctional with Agile, and this is not a place to take that dysfunctionality, because you will get caught. So guys, database sharding can be a very useful tool for making your application more resilient to load. However, it is complex and you really need to think it through carefully if you're considering using it in your environment. There are several different ways to do it with different advantages and disadvantages, and these will need to be thoroughly considered before you start. Plus, sharding is actually a fairly drastic fix, and it requires a lot of support and extra work for the remaining lifetime of your application. It's not some quick fix and the problem's gone. It's there forever. This means that you really shouldn't consider it until most other options have been exhausted, and then you should plan. And that's pretty much all we've got.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.